Okay, I'm going to do the remaining 25 questions, but what happened is the order of the question changed every time I close and open the final exam review. So I'm going to have to search through the remaining 25 questions as we do them. Okay, this is one of the questions. Match the linear correlation coefficient to the scatter diagram. The scales on the x-axis, y-axis are the same for each scatter diagram. This is a correlation coefficient. If R is very close, if R is 1, that means we have a perfect linear relationship. If R is very close to 1, we have a very positive linear correlation, and close to -1, negative linear correlation. So R is 1, should match with 3. So for A, for C, it's going to be 3, of course. And as you notice, in 2 there is a stronger correlation than 1, so it's going to be the larger number. So 0.787, which is B, that will go to 2, and then 1. Okay, match the linear correlation coefficient to the linear to the scattergram negative. Negative, then you have to have a negative slope, so it can't be D, of course. It can't be B because that's perfect. It can't be A because it looks like perfect, so it must be C. Next. We did this one. Okay. The data below represent the number of days absent X and the final grade Y for a sample of college students at a large university. Complete parts A through. Okay, so we have the number of absences X and the final grade relationship. That's chapter 4. We need to find the equation of the line. You can do that in static crunch. Just like that. Then you go to stat, regression, simple linear. Select the X variable, which is number of absences, the Y variable, which is the final grade, and compute. And here you go. This is the equation. Final grade, which is the Y, which is 88.88 minus 3.11x. So negative 3.11 should be attached to x, and then what was the other number? 88.88. Oh, 3 decimal places. So you do it for 3 decimal places. Interpret the slope. The slope is negative 3.11. So the slope means for each additional absence, the grade will drop down by 3.11. That is what it means. And what is the y-intercept? The y-intercept is when x is 0. So if the number of absences is 0, the grade should be 88.88. So interpret the slope. Number of days absence fall, yeah. For every day absent, the final grade falls by 3.3. What was it? 3.11 by 3.11 on average. Interpret the y-intercept. For 0 days absence, the score is predicted to be 88.88. And to check the line, actually you already have the line here. Let me show you. Here you go, it's right here. So you can match it with one of the answers that you have there. And then let's see what else. Would it be reasonable to use a least square regression line to predict the final grade of a student who has missed 15 class periods? Let's see. If x is if 15 is within the range of the number of absences, yes, it is reasonable. Otherwise, it's not reasonable. And since 15 is way beyond 9, then it's not reasonable. You have to select this answer. Because the linear model would work between 0 and 9, but we don't know how good it works beyond 9. R square, we did this question. Is the following a probability model? What do we call the outcome? Yellow. Well, it will be a probability model if all of them add up to 100%. So you get 35, 15, 50, 60, 85, 15. Yes, it is a probability model. What do we call the yellow? It's impossible because the probability is 0, so it's called the impossible event. Okay. Determine whether the following graph represents a normal density function. Well, it doesn't look like bell-shaped, so the answer is no. What about this one? Definitely no, it's not a normal density. Normal density has to have a bell-shaped look, so that's a no. The relative frequency histogram represents the length of phone calls and George's cell phone during the month of September. Determine whether or not the histogram indicates a normal distribution. That's not a normal distribution. It doesn't look, it looks like it's skewed toward the left. So it's left skewed curve, so the answer is no. So no, because the histogram does not have the shape. Determine mu of x bar and sigma of x bar. This is the central limit theorem. The mean of the sample means, the standard deviation of the sample means, or they call it standard error of the mean. Well, the mean of x bar according to the central limit theorem is the mean of the original population, and the standard deviation will be the original standard deviation divided by square root of 49. So make sure, just compute this. So it's going to be 28 divided by 7. You just divide the two. A survey of 2,302 adults in a certain large country aged 18 and older conducted by a reputable polling organization found that 422 have donated blood in the past 2 years. Obtain a point estimate for the population proportion of adults. Well, p hat, guys, is by definition is x over n. And x here is the 422. And n, just tab, and n is 2,302. So you just divide them and do the answer to 3 decimal places. Verify that the requirement of constructing confidence interval about p are satisfied. Well, the requirement, let's see. You can assume that the sample is a simple random sample. This is the value of p hat. 1 minus p hat should be greater than 10. So we need to find this one. Okay, how do you find this one? You already found p hat. You just multiply by n, which is 2,302, and then multiply by 1 minus p hat, and you check if this answer is bigger than 10. If it is bigger than 10, that's one of the conditions to be able to construct a confidence interval, which is larger than 10. That's definitely larger than 10. And the sample size should be always less than 5%, can be assumed to be less than 5% of the population. These are the conditions. Construct a 90% confidence interval for the population proportion of adults. I'm going to show you how to do that on the calculator. So you just go to stat, tests, and it's one prop interval, not z-test. We're doing an interval here, so one prop z interval. There you go. It's a letter. Oops, we went too far. Enter. Okay, x here is, what did we say x is? 422. N is 2302. And the confidence level he wants 90%. Just put 90% there. Enter, calculate. And here's the confidence interval, 0.17 and 0.196 or 0.20. That would be. So we are 90% confident that the proportion of adults in the country aged 18 or older who have donated blood in the past years is between. Just put the boundary of the intervals in there. Next question. In a research study, researchers wanted to measure the effect of alcohol on hippocampal region, the portion of the brain responsible for long-term memory storage, in adolescents. The researcher randomly selected 15 adolescents with alcohol use disorder to determine whether the hippocampal volume in the alcoholic adolescents were less than the normal volume of 9.02. So the claim is to test whether this is less than 9.02. An analysis of the sample data revealed that the hippocampal volume is approximately normal with no outliers, and X bar is 18.5 and S is 0.8. Once it is an S, guys, it's a t-test. Conduct the appropriate test. So first of all, the mean equal is 9.02, sorry. And mean here is less than 9.02. And remember, the claim is in H1. Okay, how do you run the test? You just go to stat. It's number 2, t-test. Enter. Okay. We're testing against 9.02, so you just enter that value. Enter. X bar is 8.15. S is 0.8. N is how many? 15. And now select the alternative hypothesis, which is less than, and hit calculate. So T0 is negative 2.52. Negative 2.52. And p-value, as you notice, it's 0.0123. And what is alpha here? 0.01. So that's bigger than alpha. Bigger than alpha, you fail to reject the null hypothesis. So fail to reject the null hypothesis. And there is not, every time you fail to reject the null hypothesis, you start, there is not enough evidence. And when the claim is in H1, you use the word support. So there's not enough evidence that the mean volume is less than 9.02. We cannot support the claim that it is less than 9.02. Okay, assume that the differences are normally distributed. Compute parts A through D. Determine D, which is X1. So these are paired samples, dependent samples. You want to find the differences. You want to compute D bar and SD. D bar is the mean of the differences, and SD is the standard deviation of the differences. And then he wants you to test the claim that mu of D is less than 0. What you can do the differences by hand. You put them here and then put them on your calculator, or you can do static crunch for the whole thing. So let me show you how to do static crunch. Okay, you go to stat, t-stats, paired. Paired means dependent samples. So paired, select the first column, which is what? Xi. Select the second column, which is Yi. And I want the differences. It's going to save them for me. And we want to test that mu of D is less than 0. So you just do less than 0 right here, guys. And that's going to give you everything you're asking for. Watch. Mu of D less than 0. Save the differences. I will see the differences and then compute. Okay. Here are the differences, guys. So you can copy them and put them in the answer. Now you need D bar and SD. Here's how you can find D bar and SD. Let me just answer the rest of the questions first. You already have the test statistic and the p-value. So this is our claim. The claim is mu d. This, you have the p-value already. Let me see what the p-value is. It's 0.0203. You just put it there. And what is alpha? 0.05. So you reject the null hypothesis and support the claim. There is sufficient evidence that mu of d is less than 0. Now let me go back here. These you just enter them manually, just from static range, or you can subtract 50.1 minus 51.6 and so on and so forth. But let me show you how to get d bars and st. So in static range, we're going to go back to static range. You already have this third column, guys, or fourth column. Here's how you find the mean and the standard deviation. Go to summary statistics, columns, and choose the difference. And just hit compute. Okay, the mean, this is the bar, negative 1.84, and standard deviation is 2.07. So this is the mean, D bar, and this is ST. Okay, that's how you get the answers. Test that mu1 is greater than mu2 at the alpha equals 0.10 level of significance for the given data set. Okay, so first of all, he wants to check mu1 is what's the null in the alternative. The null alternative will be C. Mu1 equals mu2, mu1 is greater than mu2. For the test statistic, let's use the calculator for this one. It's a two-sample t-test. You only use z-test when he gives you sigma 1 and sigma 2. Okay, it's a summary. I have a summary. So x1 bar is 54.4. S1 is 7.7. N1 is 23. And then go to x2 bar, which is 45.1. So we need mu1 to be greater than mu2. That's what the test is about. So I'm going to have to select the third one, enter. If it doesn't say anything, population variances are equal, you select no by default. And calculate. So t is 2.89 if it is 2 decimal places, and p-value is 0.0038. And he's asking you to choose the p-value. Well, the p-value is less than 0.01, of course. And we reject the null hypothesis since the p-value is less than the significance level. Don't worry about the part B confidence interval for the difference between two means. We didn't do that, so don't worry about part B. A random sample of N1 is 137 individual resulted in 44 successes. An independent sample of 144, 9 individuals resulted in 65 successes. Does this represent a sufficient evidence to conclude that P1 is less than P2? So it's a proportion test. The given situation is about the proportion, definitely. Let's write the null in the alternative. P1 is P2. So we need to check P1 is less than P2. So let me select that one. And it's a two proportion z-test, guys. Stat. Number 6. Okay, let's see. So we have x1 is 44, n1 is 137, x2 is 44, no, x1 is 44, x2 is 65. And 2 is 149. Let me double check. Yeah. And we need to check that P1 is less than P2. And you can, if you like, you can hit the draw instead of calculate. It's gonna give you a test statistic and the p-value. Oops, don't worry about this curve. Let me just get rid of it. That's what you need to be looking at. The first two curves that you saw are external. You should not see them. You see, if I clear now and I clear this, you won't see those curves anymore. So if I go to stat one more time, I think nothing changed in the settings, so let me just hit draw one more time. And now you're gonna see the p-value and the test statistics. See. So z is what? Negative 2.00. Can't see it clearly. Yeah, negative 2.00. So you just put it right here. Z equals negative 2. And then the p-value is in the range of, what was the p-value? It's 0.0227. So let's see what range we have the p-value. Between 0.1, no. 27. So it's bigger than 2%. So it's between 0.05 and 0.10. And what is alpha here? 10%. That's less than 10%. So you reject the null hypothesis. And you conclude that there is enough evidence to support the claim that proportion 1 is less than proportion 2. Next question is about independence test, section 12.2. The following data represents the smoking status by level of education for residents 18 years or older living in a certain country from random sample of 987 residents. Test whether smoking and level of education are independent. Remember, when you do independence test, the null hypothesis is always the variables are independent and the alternative, the variables are dependent. So let me find out where I'm gonna see this. Smoking says, that's it, that's A. Now, how do you find the test statistic? We can do that in using the calculator or using StatCrunch. Let me show you how to do that using StatCrunch first. You go to Stat, Tables, Contingency Table with Summary. And you select all of the columns. How many columns do we have with data? Just the columns with data. So you have current, former, and never smoked. Row labels, they're in the number of years of education. And chi-square test of independence. And if you want to get the expected count, we can get him as well. And I'm gonna hit compute. Expected count is our expected values, the E's. Okay, these are the expected counts, guys. For 182, the E value is 166.5 and so on and so forth. But what we care about is this value right here. Let me just move this a little bit. And we need the test statistic, which is 9.645, and the p-value, which is 0.1404. And the p-value is, which is big, 04, but is that what it was? Let me just, Oh, sorry, we use static crunch here. Oh, 1404 and 96,459.645. And this one. The bottom line, this is bigger than alpha. So you fail to reject HO. And what's the test now? Test whether they are independent. So the claim is in HO. So we say fail to reject HO. There is not enough evidence to reject the claim. Okay. Now construct a condition distribution of smoking status of the number of years and draw a bar graph. Does this evidence support your conclusion in part A? Okay, here's how you do this. You take the 182 and divide it by the total of the row that has less than 12. So you add 182 plus 88, that's 270, 370, 440, 449. So this is 182 divided by 449. This one will be 88 divided by 449. And 179 divided by 449. Then for next one, you do the total. 105.74, this is 182, 282, 310, 311. So that will be 105 divided by 311, and so on and so forth. Now, then you choose the correct bar graph that represents each category. That should be easy, just to check it, just compare with the data. And does this evidence support your conclusion in part A? What was our conclusion here? There is not sufficient evidence that smoking status and level of education are related. If those percentages that you get here, decimals, do not change much, that means it's unlikely to support the alternative hypothesis, and that means the null hypothesis remains valid, and that's why we fail to reject the null hypothesis. I think this is ANOVA. We did that one. You got the data in 3 different sets, so you put them in L1, L2, L3, and you run ANOVA, a one-way analysis of variance. And your null and alternative hypothesis should be always that mu1 equals mu2 equals mu3, and the alternative, at least one of the means, is different, and then you do the rest. We did this exercise. Same thing here. ANOVA test, but here you have more data to put in there. So let's do this one. Just one sec. 2 baseball playing statistics students collected data on baseball player run times. Players were required to run 50 meters and were timed in seconds. Pitchers did not have to run. Assume the distribution of each population are close enough to normal to satisfy normal condition for using ANOVA. So it's ANOVA test. Test the hypothesis that different positions have different means. So the claim is in the alternative, because the null hypothesis always the means are equal and the alternative one mean is different. So it's going to be this one and the claim is in HA or H1 if you're using H1. Here's how you do this one, guys, using StatCrunch. You can put the data in L1, L2, L3 and run ANOVA under test, but let me show you how fast it is to do StatCrunch. Just go to stat, ANOVA, one way, select the columns, and all they need, that's it, hit compute. And look, guys, you look for F here, which is 7.81, and the p-value 0.0022. 0.0022, which is less than alpha. So you reject the null hypothesis, and there is enough evidence to support the claim that they are different. So let's see which one is going to be. it's C. There is sufficient evidence to conclude that different positions have different mean run times. Okay, the next question is goodness of fit test, section 12.1. Several years ago, a study of college freshmen found that 28.7% of incoming freshmen characterized their political views as liberal, 28.7% liberal, 51.1% a moderate, 20.2% as conservative. For this year, a random sample of 500 incoming college freshmen yielded the following frequency distribution for political views. Complete parts A to B. Identify the population variable under consideration in here. So the population is all incoming freshmen, and variable under consideration is political view. At the 5% significance level using p-value, do the data provide sufficient evidence to conclude that this year's distribution of political views for incoming freshmen has changed from the distribution found in the study, which was given to us at the very beginning? Okay, your null hypothesis will be the distribution is as claimed, and the alternative will be distribution is not as claimed. So let's see what the wording that works here. Differs, no, it can't be the null. Distribution differs, okay, that must be A. Is the same and is not the same. That's what we need, A. Okay. Now compute the value of the test statistic. Well, these are the observed values, the frequencies. You need the expected values, and so we have to find the expected values first. And let me show you how we're going to find the expected values here. So for the liberal, it's 28.7%. So you take 0.287 and multiply by the 500, the grand total. Then you take, what was the next percentage? 51.5. So 0.515 and times 500. And then the last one, what was it? 20.2, so 0.202. Times 500. Okay, so using calculator, here's how we perform goodness of fit test. First of all, you have to compute the expected values. 0.287 times 500, 0.515 times 500, 0.202 times 500. This is 143.5, 255.5, and 102. And let me show you how to do the calculator. First of all, you go to stat and edit. And you put the observed values, which is a 146, 237, 117 in L1. The expected values, which I did by hand. You have to do this by hand. 255.5, 101 in L2. And then you go to stat, tests, scroll up, and it's D, goodness of fit test. Chi-square goodness of fit test. Enter. L1, L2. Degrees of freedom, if number of categories -1. So I have 1, 2, 3, liberal, moderate, conservative. So that will be 2. 3 minus 1 is 2. And calculate. And here you go. Test statistic is 3.1917 and the p-value is 0.1410, which is greater than alpha. So you fail to reject the null hypothesis. And what is the claim? The claim is... okay, let's see. Is there something to conclude that this year distribution has changed? That means the claim is in H1. Since we failed to reject the null hypothesis, there is not enough evidence to support the claim. So no, because there is not enough evidence to reject the null hypothesis. Yeah, we cannot reject the null hypothesis when p-value is more than alpha. Now to do this one using static range, let me show you how to do that. It's static range. Okay, you need to enter the expected values. So you got the frequencies, you need to enter the expected values. So 143.5 and then 255.5. And then what did we get? 101. And now I can show you how to run the test. Stat, where's the goodness of it? Right here. It's a chi-square test. Select the columns frequency, select the expected, it's in variable 3, and just hit compute. That's all. And you guys, you can see this is the chi-square, exactly what we got in using the TI calculator. 3.917 and 0.141, which is bigger than alpha. You failed to reject the null hypothesis. Okay, perform a chi-square independence test, section 12.2. Provide the condition for using the test, provided the conditions are met. Researchers studied the bone mineral density BMD in depression of men aged 65 to 92 at the 1% significance level. Do the data in the table taken from random sample provide sufficient evidence to conclude that the bone mineral density and depression are dependent? For independence test, the null hypothesis should be variables are independent, and alternative should be variables are dependent. So let's choose the correct one. Depression, and okay, not that one. It can't be A because it says dependent in HO. Yeah, that must be B. Now, how do you find the chi-square test? If using the calculator, guys, this is what you have to do. Your data is in 1, 2, 3 rows and 2 columns. Don't count the totals. Totals don't count as actual data. So we go to matrix. You press second and matrix, and then you press edit, and you make sure that you create a matrix with 3 and 2, 3 by 2. You put 3 rows and 2 columns, and I already put the data in there, so just to save time. So we have the data in a matrix, so I'm gonna quit now. Okay, so done. And now we're gonna go to the calculator one more time, show you how to perform the test. Stat, tests, scroll up. It's chi-square test, C. Enter. The observed values in A, the calculator is going to put the expected in B. That's all you have to do, nothing. Just hit calculate. Test statistic is 16.28, and the p-value, don't ignore the E minus 4. That means it's 0.00029. So when you round the p-value to 4 decimal places, it's gonna be 0.0003. Just make sure that you round it properly, which is less than alpha. Reject HO. Oops, reject HO. And we want to check if they are dependent, so that means the claim is in H1. So yes, when you reject the null hypothesis, if the claim is in the other one, you support the claim. So the data do provide evidence that they are related. Now, how would you do this one using StatCrunch? Let me click here, open in StatCrunch. Okay. Stat, tables, contingency with summary. Okay, where is my data? Is columns. I have variable 1 and variable 2, right? So variable 1, shift. Row labels, I don't have a label there, so it didn't put, that's fine. And then hit compute. Oh, variable 3, 2 rows. Let's do that again. So stat, tables, contingency with summary. Select the columns. Oh, I made a mistake there. In variable 2 and 3, the columns data. And then the row labels are in variable 1. As you can notice, variable 1, this is where the labels of the rows. Now it should work. Let me show you what I'm doing here. Just hitting compute. And look, this is the test statistic 16.284, and that's the p-value, exactly what we got, 0.0003, which is less than alpha. So you reject HO and support the claim. Okay, a board of governors published information on family net worth. In 2010, the mean net worth of families in particular country was 487.8 thousand, and the median net worth was 79,000. Which measure of center do you think is more appropriate? Definitely the median, because the mean will get affected by extreme values, those very wealthy people that will inflate, the salary. So the median, because it's not strongly affected by the relative few families with extreme high net worth. Okay, that's the last question out of the 50. Listed below are time intervals between eruption of a geyser. Assume that the recent time are within the past few years. The past times are from around 20 years ago, and the two samples are independent. So it's a two-sample t-test. Do not assume population standard deviation are equal. That means pooled is no. Does it appear that the mean time interval have changed? So have it changed? I think we did this question. So equal or not equal. So you just select that one. How do you get the test statistic, guys? It's just open in static crunch. And you go to stat, t-stats, two sample with summary. Oops, sorry, not with summary, with data. Stat, t-stat, two sample with data. Select the column, recent. Select the column 2, past. And no, don't select this one, and then we're doing different from 0. It's already been selected for us, and hit compute. So the test statistic is negative 2.09. You can see that right here, and the p-value is 0.0469. Let me show you, 0.0, which is 0.047 to 3 decimal places. That's what's alpha here, 0.10. That's less than alpha, so you reject the null hypothesis. And he asks you again to do it later with 0.01, then it's more than alpha, you fail to reject the null hypothesis. So it's 2 questions in 1. If the p-value is less than alpha, we reject HO and support the claim. So there is enough evidence to conclude that the mean time interval has changed. Is the conclusion affected by whether the significant level is 0.10? Definitely, because if the significant level is 0.01, we will fail to reject the null hypothesis, and we conclude that there is not sufficient evidence that the mean time interval has changed. So it does make big difference. That concludes the review.